This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC, is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EDO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute, waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS Apex spacecraft is at its closest approach to Earth. That will be on to its extended mission, visiting the asteroid Apophis in the year 2029, continuing this incredible mission that just a few years ago was on the other side of the solar system from us, sampling at asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. We see
EDO milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety of different tracking assets. And you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale to the rugged terrain of the Utah Test and Training Range. It looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, the slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. According to my watch, we're about 5 minutes away from landing with our SRC. And as we heard a few moments ago, helicopters 1 and 2 are already staged and ready to begin those recovery operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
EDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there, as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath. The team on the WB-57 doing
EDL milestone. We have touchdown. I repeat, EDL SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It's a pleasant sight for the team to see.
Recovery operations. Helo 2 has visual on the SRC. I repeat, SRC has been located.
And we have visual on that SRC. It appears that the parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield that protected it the whole way down through that entry, descent, and landing. Lockheed is celebrating that moment. I'm sure they are breathing another sigh of relief here. It's been a wild morning for everyone involved. They've been up since the crack of dawn just a little bit further north from us in Waterton, Colorado. They gave the go command to actually release that SRC that you see on your screen right there from the OSIRIS-REx spacecraft about 4 hours ago. It then ventured entirely on its own and now sits on its own for us here in the Utah Test and Training Range. So now that we have visual, the teams should be able to begin the recovery operations in just a few moments. As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley. He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it there, just a little bit off the edge of our SRC. The SRC looks quite charred up from that entry in. That was expected as we heated up to temperatures over 5,000 degrees Fahrenheit upon entry into Earth's atmosphere. You can see a great visual of some of that rugged terrain out there. Just a sweeping expanse, very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample The team looking a lot more relieved now that we actually have visual. And we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid Regolith. This mission continues to amaze me and everyone involved here. The engineering is ingenious for this mission, getting us with a robotic explorer to the edge of the solar system, collecting that sample, safely stowing it, and then actually transporting it back here to Earth for us to open up and analyze.
All right, as anyone who pays just even a little attention to modern spaceflight knows, there has been more activity above the planet in recent years than ever before in human history. There are probes like OSIRIS-REx moving around the solar system, observatories looking out into deep space, and satellites closely examining the health and future of our own planet. There are also human explorers, and we are so fortunate to have two of them with us here today. Joining us now are NASA's astronauts Butch Wilmore and Suni Williams, scheduled to launch on Boeing's crew flight test aboard Starliner to the International Space Station. Butch and Suni, thank you for joining us today.
We are honored to be here.
Super exciting day.
What a thrill.
Congratulations.
Absolutely historic. How are you feeling?
Pretty amazing.
It's like, wow, this is what, dreams and imagination is fueled with. This is just amazing. So, it can go from the movies, but this is reality, and we're doing things that people couldn't even believe could happen. It's amazing. Yeah.
And also, I mean, we both landed under capsule, under parachutes. There's not much better feeling when that parachute opens, I'm telling you. And it was maybe not equal,
obvious.
pretty close to exciting and intense, and that parachute opened, oh, it was thrilling. Absolutely thrilling.
Yep.
Yeah, it's fantastic.
Well, that is fantastic. One of the things that I think will be really interesting is this, of course, this site is being considered as one of the candidates for the Boeing Starliner crew flight.
Right, and that's actually why we're here. It just worked out in our timing for our training and as we're working on Starliner, that we could come and actually view one of our prime landing sites, which is here at Dugway. And so that's actually what brought us to the area, so we could be here and sharing the experience with you today.
And we see this has gone so well, we are ready to land.
Recovery
here, too.
operations.
That's the place that our flight
The recovery team is performing their
This
safety
is a
huddle.
beautiful place. It's a beautiful day this morning. No wind. I think the capsule just came right down under the chute, and hopefully we'll have a nice soft ride just like this
hope
capsule
so.
too.
Absolutely. And we just got a call out that the recovery team is performing their safety operations. Everything nominal.
So
good.
you guys will be coming back and maybe someday with samples yourself, brought back by humans.
Indeed.
What do you think about that?
Again, we're in that era of going beyond low Earth orbit now with humans, headed back to Moon and potentially one day to Mars with the Artemis program. And it is a thrilling time, as you mentioned earlier. So much taking place within the solar system, the near solar system now, and it's fascinating. Great time to be in human space.
Awesome.
I think I'd be a little bit nervous to go to an asteroid, so,
Wise
so
woman.
I'm
She's
super
wise.
glad the spacecraft did it, and we'll set the pace and show us how to do it. But I think
Absolutely.
maybe you'll practice a little bit more before we go, because it's
Good
a
idea.
it's a dangerous
sounds good.
environment
Right.
learning about it.
So much stuff.
Suni and Butch, thank you so much for joining us
Oh, we
today.
appreciate
Hopefully
it.
you'll stick around for more of the show.
Yeah,
All
honored to
right,
be here.
congratulations,
Thank you,
guys.
guys.
Everybody out
Thank you
there.
Really
so
appreciate it.
much.
Thanks, guys. Good luck with your flight.
If you've just joined us, this is special live coverage of NASA's OSIRIS-REx asteroid sample return mission. You might be thinking, this doesn't look like a typical NASA facility. And it's not. In fact, it's because of the extraordinary capabilities that we find here, that we find ourselves in the Utah desert in the first place. We're coming to you live from Army's Dugway Proving Ground. We've got a video postcard to share that will give you a better sense of the glorious desert environment all around us. Take a look. Wow. Absolutely gorgeous. The spaces here are vast, rugged, beautiful. I mean, you got to see a little bit from the NASA helicopter, but that was a close-up and personal look.
And look at this. We're in this place that almost looks like Mars, but on Earth, as we're recovering a capsule with the pieces of our universe that will tell us about the early time of our solar system that we can't get anywhere else. And there's the crew out there approaching that beautiful capsule that did the joyful ride from that top of the atmosphere down. 13 minutes of roller coaster riding, and they're getting it safe and ready to start bagging her to come over to the clean room here.
Wow. And explain, why do we do a land landing, you know, as opposed to an ocean landing.
So many of our crews land in the ocean, as
Right.
you know from Apollo. But for this one, we need to bring it back to a place where we can contain the contamination. By landing in the desert here, we can keep the Earth's ocean, all those absolutely wonderful waters out. This is the best place to bring home this kind of capsule. And look at her. She landed perfectly. Looks like a top sitting there.
Absolutely gorgeous. Well, this isn't the first time that NASA has visited Dugway, and it certainly won't be the last. Take a look.
Right.
When bringing a sample of the cosmos back to Earth, it's important to find a good landing zone that won't compromise the sample. That's why NASA partnered with the Army's Dugway Proving Ground. Its vast open space makes it
Recovery
ideal for the
operations.
task.
Science
But
team is marking the
OSIRIS-REx is
perimeter
neither the first
and approach
nor the
path
last mission to land
to
here. In
SRC.
2004, the Genesis mission landed here at Dugway, delivering our first ever samples of solar wind. In 2006, NASA landed at Dugway again, this time with a mission called Stardust, which gathered samples of interstellar dust. Both of these missions helped fuel our understanding of the universe and wouldn't have been possible without a safe landing zone, just like OSIRIS-REx. After today, NASA and Dugway are looking towards the future to the Mars Sample Return mission that will once again be bringing a unique sample of our universe right here to Dugway Proving Ground. The U.S. Army and Air Force have been excellent hosts to us for months as we've been preparing for today's landing. That's one of many reasons I'm so pleased to welcome Colonel James Harwell, Army Commander here at Dugway Proving Ground.
Recovery
Colonel,
operations.
welcome.
Nominal SRC recovery operations have
All right, we're
begun.
getting an update. Okay. All right, nominal SRC recovery operations have begun. Okay.
You darn good.
All right. Okay, so today could not have gone any better. How did it, I mean, in large part due to our amazing partners here with the military, how did it look from your end?
Oh, it looked amazing. So when you talk about partnerships, this isn't just a Dugway Proving Ground effort. Though you're sitting here on Dugway Proving Ground, the capsule actually landed on the Air Force's Utah Test and Training Range, and so it's going to be brought here to Dugway before it goes to the clean room. So this is a larger effort than just the Army's Dugway Proving Ground and NASA.
And it looks like it might have landed right.
So I got a note just before this from the commander of the Utah Test and Training Range that it did land on Uter. And so there was a little bit of rivalry there. We were hoping, but it looks like it was on Uter.
Right on the boundary, though,
Yeah.
so close.
So we have a big collaboration at NASA with members of from the Army and Navy, from the military services that have given us the opportunity to go to these great places in space ourselves as people. And can you tell us a little about the training and other fantastic things you do prepares these people to be crew for flight into space?
Yeah, so if you look at it, the Army is the greatest leadership lab in the world. The types of problems that we have to solve on a day-to-day basis. And we have some of the best workforce that is available. So here at Dugway Proving Ground, we do chemical and biological defense testing. We're part of the Army's Test and Evaluation Command. And so anytime a piece of equipment is going to go into a service member's hands, it's tested by one of our amazing members of our workforce. But we also do training here. And so it gives a chance for folks to come and do things in a realistic environment. And that's really allows them to hone those problem-solving skills.
So that's why the crews are so good who come from the Army and the Navy and the Air Force.
Yeah, we'd like to point out it was an Army astronaut this week who went over who set the record.
Oh, well,
Yeah.
there you go. There you go. Well, we couldn't let you go without wishing you a very happy birthday today. Happy birthday. Today
Thank
is your
you.
birthday, and you got a piece of the solar system. How about that?
I don't think I could have gotten a better present from NASA.
No.
And this is the rarest stuff we've ever had on Earth.
It is, and I mean, when we're talking about the origins of life, and that's one of the I have the coolest job in the world. A couple months ago, I was here, and out on the Utah Test and Training Range, we got to go out to an archaeological site and see 12,000-year-old footprints. And now we're going to get to see the material from the origins of the solar system. I think we've set the bar pretty high,
really
and so
have.
my kids think I'm cool today. I don't know what we're going to do to top this.
Well, we think you're pretty cool,
Yes.
too.
Yes, sir.
And thank you so much for joining us. We've really loved having you.
Thank you
sir.
so much.
All right, let's go, OSIRIS-REx. I love that energy.
I do too.
All right, Jim, you know, you're a planetary geologist. How did you get into this? I mean, these kids are just at the beginning of thinking about what their career might be. I mean, how did you do this?
I think all kids are intrinsically curious at birth. My mother said I was interested in space at birth. Don't know how she knew. But in any event, I think we all are, and we follow different pathways. If you see things as beautiful as we have here in Dugway, here in Utah, you'll be inspired by the rocks and the things in space, like these special samples we've brought back, which are unique being from Bennu, but not unique in the kinds of materials we have here on Earth, thanks to other asteroid returns. These are the biggest we've ever done, and so we're excited. But I think curiosity is in all of us, and so that's really what it's all about. And these kids are ready to pick up on this energy.
Yeah, we need that future generation. All right, let's get an update from James. James, go ahead.
Yeah, Lauren, so the mission operations team has confirmed that we are able to begin those recovery operations. You've been seeing on your screen in the bottom corner for the past couple minutes, team members beginning to head out and put flags of areas of interest where we'll want to sample for our sample curation team. And also just a note on our parachute deployment, the parachute was set to deploy based on capsule deceleration, and we actually reached that threshold earlier than predicted, and the parachute deployed appropriately. So everything was right there, working perfectly fine. We got that SRC, as you can see, successfully on the ground. It is perfectly resting on the desert terrain, and you see 3 of our team members around that capsule beginning to place flags to begin to collect samples. The team members here you see on screen are Scott Sanford, Dante Loretto, the principal investigator at the right of your screen there, and Francis McCubbin. These are key curation team members who will help us actually get a lot of these samples of the region there, environmental samples, collected and ready to be passed along to our team at the Johnson Space Center for curation efforts there. This is, again, a very key part of the mission. We want to make sure that there is no contamination of that sample return capsule from any possible atmospheric or environmental conditions out at that landing zone, that landing site. And so we're going to continue these operations and actually begin to scoop up some of the samples. And this will work like a well-oiled machine you'll see in a few moments. Dante, who was just on your screen a few moments ago, is wearing an armband, much like a football quarterback, if you will. He'll actually be kind of reading off the play calls as they go out and go step by step to actually scoop into the terrain about an inch down into the surface of the desert, scooping out a little bit of the rock and dust that's there, placing it into a bag, photographing the whole process along the way, making note of exactly where they collected that sample from. All this information will then be passed along to our sample curation team at the Johnson Space Center as they begin to actually open up that sample canister and see exactly what we got within. This has been a long journey. It's been an incredible morning to witness this live. Just such a stunning feat of engineering to get that capsule back here to Earth with samples of the asteroid Bennu. This is why we do science, right? To get these kinds of samples, every piece of dust and grain inside that sample return capsule is a PhD thesis waiting to be written. It's a new discovery waiting for us about the origins of the solar system and our place in it. And the vast majority of that sample, more than 70% of that sample, is actually going to be stowed away for future analysis. We did the same.
All right, at CCSV wants to know, will the sample be quarantined like moon rocks are?
Well, in this case, based on a classification of what we call the planetary protection, these samples will not be quarantined in that way. The first moon rocks came back, they were quarantined for a week, out on the carrier and all that kind of good stuff, came back to Houston again very carefully. In this case, we understand the asteroid, the environment, we measured it with OSIRIS-REx, other asteroid samples from our colleagues in Japan, and so we don't have to quarantine them the same way. We do have to protect them, though, from contamination, and there's all kinds of systems in place by our team to allow us to understand the level of contamination. So what we study in science is the pristine asteroid.
That was a great question.
Excellent question.
Excellent question.
Recovery operations, SRC is bagged and secured in the handling fixture.
All right, you just heard that the SRC has been bagged, and we are well on our way to getting that to our clean room here at Dugway. Wow, fantastic news. Missions like OSIRIS-REx transform scientific pursuits into engineering challenges. Smart, curious people with pursue answers with creative verve and perseverance. This year, Hollywood also had a story about a crowd of people situated around the touchdown point of an asteroid. And, well, we couldn't help ourselves. We asked the cast of Asteroid City to say a few words. All right, well, it looks like we are having some technical difficulties, but that's okay. We'll definitely get you that video. It's a really fun one.
It is.
Scarlett Johansson, I mean, A-lister,
Yes.
Can you imagine? All right, so let's get an update from our field correspondent, Sophia. Sophia, do you have an update for us?
Okay, Lauren, turns out the landing site really is just over my shoulder. It is just so hard to see through the alkaline particulate out here on the landing zone. But you know what? This is all in great hands, and we are just very thrilled that the capsule is doing well today. So I'm able to see one of the helicopters just circling over there. But for those of you who have just tuned in, I am on Wig Mountain, which is overlooking the ellipse, which is the vast landing zone. And earlier today, the helicopters, which were shuttling our teams of experts and our scientists, departed from here via helicopter once they found out exactly where the capsule landed. And now they're off on their recovery process and are doing what they do, which has been a carefully rehearsed process. So, Lauren, I'm going to send it back to you.
Great. Thank you so much, Sophia. All right. Well, let's get back to that awesome video of Asteroid City. You don't want to miss this. Take a look.
Hi, I'm Jason Schwartzman.
I'm Jake Ryan.
And I'm Scarlett Johansson.
Where are you?
Asteroid City, Farm Route 6, mile 75.
Hey everyone, I'm Jeffrey Wright. Junior stargazers and space cadets. Each year we celebrate Asteroid Day.
Hey everyone, I'm Maya Hawke.
And I'm Rupert Friend.
And we star in Wes Anderson's new movie, Asteroid City.
In the movie, families from across the country gather in a fictional American desert town for a junior stargazer convention.
I heard there's a real-life reason people will be gathering in the Utah desert this September.
The world will never be the same.
What is happening there on September 24th?
September 24th is going to be a historic day. This is NASA's first asteroid sample return mission and the biggest sample return beyond the moon. Shortly before 9 a.m. local time, the OSIRIS-REx spacecraft carrying precious samples of asteroid Bennu will release the capsule into the atmosphere to lower the samples down to the Utah desert, where scientists are anxiously awaiting the return of these materials.
Wow, that sounds like the plot of a science fiction film.
It's incredible that a spacecraft can go to an asteroid,
grab some pieces of it, and then bring them to Earth.
So what will NASA look for within the asteroid sample?
These pristine asteroid materials will be studied by scientists from around the world. We're going to be looking at the minerals. We're going to be dissecting the rocks, looking at it mineral grain by mineral grain to learn more about how the solar system formed and evolved. We're also going to be looking for water to try to understand how our Earth's oceans came to be. And then finally, we're going to be looking at organic compounds, including some of the basic chemical building blocks of life, to try to understand whether asteroids like Bennu could have delivered the building blocks to Earth, leading to the origin of life on Earth and potentially elsewhere. With the data that we obtain from these materials, we're going to be rewriting the textbooks on solar system formation.
Fascinating stuff. But don't fragments of asteroids land on Earth all the time? Why can't we study those pieces instead of a mission to bring this sample to the Earth?
Yeah, that's a great question. I mean, in fact, the Earth is constantly being bombarded by fragments of asteroids in the form of meteorites. But one of the big problems with studying meteorites is you don't always know where they came from, and it also can be contaminated.
Fair enough. It makes sense that we'd want to study something more pristine.
So how will NASA protect the sample once it's on Earth? And can I have some?
Oh, I wish we could have some of these samples. I wish I could bring one home with me to put on my dresser at home. But the reality is these samples will only be for educational purposes and scientific research. The samples will be transported to the NASA's Johnson Space Center, where they built a special curation facility just for keeping these samples safe and pristine.
This is also incredible. I'm so glad that NASA has teams of people that are searching for the answers to some of the biggest questions, like where did life and water come from? Where did our solar system come from?
I can't wait to see what we learn from the asteroid sample OSIRIS-REx is bringing to Earth. Thank you for all that you do.
This is also incredible.
Thank you so much for all you do.
Well, you just said that name. You just said OSIRIS-REx. That was the thing.
That was kick-ass.
How did you do that? I was like, what is this phrase?
I was like,
OSIRIS-REx.
OSIRIS-REx.
Yeah, OSIRIS.
It was great.
OSIRIS-REx.
This will be the last time the SRC takes flight. We had a wild flight this morning. You can see two team members lifting that SRC up. It's about 120 pounds total once you have the SRC and the carrying fixture there together. They're going to be walking this over, preparing it for cargo netting, and getting that attached to the long line for helicopter operations. And as I mentioned, this is the last time the SRC is going to be taking flight. It had a harrowing journey this morning coming through the Earth's atmosphere at over 27,000 miles per hour. It is now being carried carefully by a couple team members here. So quite a deceleration from that initial entry, and really just a wonderful final journey for our sample before it is opened up at the clean room and prepared to be shipped to the curation facility at Johnson. And you can see we have the cargo netting already laid out there. Our representative from Dugway, Jasmine Nakayama, is prepared with that cargo netting. She's going to help the team here get that SRC that has already been successfully bagged up with thermal wrapping into that cargo netting. And you can see the helicopter already there, staged and ready to lift off. The helicopter pilot has actually removed one of the doors on that helicopter so he can lean out and look down as he carefully lifts the SRC off the terrain. We want to make sure that this is a careful, slow process as we safely transport this SRC to the Dugway clean room. And you can see Jasmine is picking up pieces of the cargo netting and beginning to wrap the SRC that has been placed already on the carrying fixture with the thermal blanketing. Team members observing their handiwork of getting that carefully wrapped up. We'll then actually unwrap all of that thermal blanketing once we actually get it into the clean room here.
Recovery operations, SRC is in the cargo net, and all the gear has been stowed in the helicopter.
And this will be, once again, a very slow, deliberate operation. We want to make sure that sample return capsule is safe as we are lifting it off. The piece that Jasmine is holding in her hand right now is that gimbal stabilizer for the cargo netting. That will ensure that the SRC is not wildly spinning as we get to altitude with our helicopter. These helicopters can get upwards of over 100 miles an hour speed, but we're going to go nowhere close to that today. We're going to be taking this at a slow pace, making sure that SRC can get back safely and securely to our Dugway clean room. You can see one of our NASA photographers, Keegan Barber, taking some great pictures. I'm sure those will be phenomenal views of the operations that are going on just across the way from us at the Utah Test and Training Range. As soon as these rotors get up to speed, our helicopter will get off the ground. The terrain is a little bit soft today. Team members were out here yesterday testing out the grounds and had practiced actually landing with some of the helicopters. Those skids on the helicopters got about an inch into the wet terrain. It's presumably dried a lot more today. It's the sunny, clear skies have probably helped us out a bit, so it should be an easy liftoff for this helicopter to get into the air and help transport that SRC to the clean room. Off-screen, team members are presumably continuing to collect samples of the surrounding area, both environmental, soil samples, atmospheric samples. We'll be continuing to do those operations even as we bring this SRC to our clean room. Just a great view here from our NASA helicopter. And in just a few moments, we should have a stunning view of our SRC lifting off the ground. No part of this SRC comes in contact with the helicopter. As I said, it's been safely stored in that thermal blanketing. There's multiple layers of that blanketing, as well as a tarp being placed over it. Now it is also in that cargo netting, thanks to our Dugway representative, Jasmine Nakayama. She's then attached this whole contraption to a long line that will dangle about 100 feet below the helicopter. And I can see a lot of dust kicking up now. The engine's really revving up on that helicopter, and it is off the desert terrain in the air with the SRC in tow.
Recovery operations. Helicopter 1 is cleared to depart the recovery site with the SRC.
And we have clearance to depart the recovery site. This is a key moment of those recovery operations. We're already getting that SRC out of the landing zone and on its way to the Dugway clean room. In just a few moments, that SRC with the long line attached will be lifting off its landing zone. Jasmine assisting with that final part of the lift, and it is now airborne. As I mentioned, a much more relaxing flight for our SRC on its last leg of its journey. We are officially departing that landing zone. Recovery operations will continue out at the Dugway clean room. I see team members waving goodbye. And look at that view. This is a stunning view of our helicopter. This is a long journey ahead. As I mentioned, probably about 20 minutes of total flight time. We may lose signal as we head out there a bit, but for now we have a stunning view of our helicopter carrying the SRC below, and you can see that stabilizer is helping to keep that SRC nice and stable below. We'll continue to track this transport to the clean room, but for now, back to you, Lauren and Jim.
Wow, check out that epic shot. Check it out.
What a ride.
Wow. All right, thanks, James. The science community has serious questions about asteroids like Bennu for a long time. What are they made of? Do they hold any clues about the origins of life on Earth or elsewhere? And what can they tell us about our past and potentially our future?
It's all about chemistry, Lauren.
It absolutely is. Well, fortunately, Jim, we are joined by somebody who specializes in the kind of chemistry that you'd be hard-pressed to find outside of NASA. Jason Dworkin is the OSIRIS-REx project scientist. Welcome.
Welcome, Jason. Thanks for
coming. And congratulations. What a historic day.
Oh, it's
you
just
must be so
fantastic, yes. Relieved, invigorated, excited, and
As we
so
all
much
are.
work ahead of us.
Right.
Indeed, indeed.
Fun work.
Fun
Oh,
work.
no, epic work.
Epic work. You must be so excited to dig into the sample yourself. But what makes this sample? You know, we've continued to say this is such an important sample from an asteroid. Why is it scientifically significant?
So Bennu is an ancient piece of the early solar system, a leftover component. It's a fragment of what happens when you make planets, and this fragment of rock it contains the ingredients that happen when you make planets, that happens when you make life. Right. So by studying a sample from the leftovers of space, we can study a sample from the leftovers of the formation of the Earth. Look at the chemistry in detail as you can only do on the ground using instruments that are sometimes bigger than a launch pad, let alone the rock and the spacecraft. So we can interrogate the compounds, the minerals in fine detail to understand how they interact with each other and how they could have led to the history of the solar system.
And that's forensic science at its best. But I have a question, Jason, because you're an expert in this. So we're going to save some of this sample so that future generations, future techniques, future people not even born can learn from it in the future as we try to look at our place in space.
Absolutely. That's one of the parts I find the most exciting and gratifying, is that the work we do here will be available for scientists perhaps watching now, perhaps not yet born. They can make choices and come up with their own hypotheses, their own ideas, their own new techniques to look at the sample in new and exciting ways, just as we have for the Apollo samples. A woman in my laboratory studied Apollo 16 and 17 samples that were collected before she was born, using techniques that were not invented in the 1970s to then answer questions that were thought of but couldn't be answered.
That's
and so
incredible.
Since you mentioned forensics, we also have equipped future generations with the information to follow the chain of evidence from the construction of the spacecraft all the way to the collection now and then the distribution.
Awesome, Jason.
Wow, that is so cool.
Thank you.
Well, thank you so much for joining us.
Pleasure. Thank you.
Thanks, Jason. Good luck.
Careful handling of this asteroid sample is all about getting the most out of the huge effort to visit the object in the first place. Mission planners considered many destinations but settled on Bennu. Let's learn more about why. OSIRIS-REx was designed to retrieve a sample from asteroid Bennu and return it to Earth. So, of the more than 1 million known asteroids in our solar system, why Bennu? First, as a near-Earth asteroid, Bennu is easy to reach. It takes about 14 months to orbit the Sun and comes close to Earth once every 6 years. To get there, OSIRIS-REx was launched in 2016 on an Atlas V rocket with a single booster and a Centaur upper stage. It also got a big assist from Earth's gravity in 2017, allowing it to match Bennu's orbital tilt. The second reason that Bennu was chosen was its size and spin rate. Bennu measures about half a kilometer in diameter and rotates on its axis once every 4.3 hours, which is actually pretty slow compared to many smaller asteroids. This allowed OSIRIS-REx to map Bennu's surface up close, and to match its velocity, briefly touch down and collect a sample. Before OSIRIS-REx arrived, scientists thought that Bennu's slow rotation meant a low risk of flinging away most of its sampleable material. But shortly after arrival, Bennu was caught on camera ejecting hundreds of pebbles. It turns out that Bennu regularly sheds small particles, but it still had plenty of loose material left on its surface for sample collection. The third reason for choosing Bennu was its composition. We don't know what ingredients were present during the formation of life on Earth, but primitive asteroids like Bennu serve as time capsules, preserving material from the dawn of the solar system. Spectrometers on OSIRIS-REx confirm that Bennu is rich in carbon-based molecules, including organics that are the stuff of life. When the Bennu sample is analyzed, it will help scientists to better understand the formation of the solar system and our own origins. So why this particular asteroid? Proximity to Earth, the right size and spin, and a carbon-rich composition. That is why we chose Bennu.